There's 16 individual steps that go into every alloy power meter and multiple more that go into a carbon meter. But the first thing that we do with an alloy arm is to bond all the strain gauges in the housing properly and make a product that will work the lifetime of you owning your bike and your power meter. We have to prepare the crank, and the first thing that we do is we remove all the finishes so we have raw aluminum. If we have raw aluminum, then we can bond and clean and ensure that the strain gauges are going to be part of the crank for life. If the strain gauge ever moves, your power numbers are not going to be accurate. So it's a really critical part for us to get that crank clean. We've spent a lot of time figuring out exactly which laser to use in the settings, because what's really important is not only to remove the finish, but we also want to get the right texture so we have the right adhesion to the strain gauge and to the alloy crank itself. The next critical step, and one of the most critical steps, is applying the strain gauge and bonding the strain gauge to the crank arm. And to do that, we have to have the right cleanliness, we have to have the right amount of glue, the right type of glue, the right amount of pressure, and the right amount of heat. And if you get all that right with the strain gauge and the gluing agents that we use, then we know for sure that that strain gauge will be bonded to the crank for life. And then after we do that, we clamp them with a specified torque and then go into ovens at the specified temperature and the specified time. Now, it's not the same for carbon and alloy and different models in the alloy. It depended on what type of glue and gauge we're using on those materials. All those steps, the process time can change. So at that point, when we're done bonding and it comes out of the oven and we clean up the arm, it's time to add the electronics in the housing. So to add the electronics, it's a simple soldering of all the wires and making sure that we've got them soldered. However, this step we do a lot more than just solder. We want to test the strain gauge, we want to test the connectivity with Bluetooth, we want to test the temperature sensor. So we run it through a series of tests, and we'll run through every single power meter. It doesn't matter if it's Team Sky's, indoors, or yours that we're building for you today. It runs through all the critical features of that. Now that we know that the strain gauge, accelerometer, all that type of stuff is working properly on the power meter, we have to bond the housing to the crank arm itself. And as you saw with the laser edge, we don't want to put any holes or change the integrity of the crank arm itself. We have to bond the plastic housing to the aluminum crank arm or into the carbon, depending on which model you are. So the real trick of this is bonding it so it's strong enough that it will never come off mountain biking, that it's watertight, and that it's flexible enough that when you bend the crank arm, you're not bending the housing. So we use this robot that puts the glue down exactly the same amount every single time and places the plastic in the same place. Every model has its own unique program on the robot, so the robot follows all the shapes and contour. So now that we have it bonded and it's dried and it's permanently part of the crank, we have to calibrate every single arm. It doesn't matter if it's a Dura-Ace 9000, doesn't matter if it's a Steages carbon arm, they all have slightly different ways of bending. So the way we do that is we bend them to a known weight. Once we take a reading in this position and then load it and bend it, then we can calculate how much it bends at every force. So every single one of them goes through this process. And again, part of the challenge for us is the quantity of power meters we make is the fixturing and tooling to get it through. So we make fixturing for every type of BB interface that we make, and we've come up with creative ways of making it fast to switch from one to the other. One of our key features is that ours is automatically compensating for temperature, no matter if you zero reset before the ride or not. When you go out and ride, cold or hot, it is always paying attention and measuring the temperature, and it will adjust for that during your ride. Now that we've got it calibrated both to force and temperature, we have a power meter that's ready to be out and ridden, knowing that it's going to give you the accuracy and consistency that we expect and that you expect. There's one last thing that we want to test, and that is we 100% test every one of them to make sure that they're watertight. We spent a lot of time going through all these complex tests and trying to figure out the most sophisticated way to make sure that it would never leak. Turns out we came up with a really simple one that works the best and the most consistent. But we actually put a battery door with compressed air on every single one of them and dunk them in water. And if the glue job is not right, if there's any tiny littlest leaks or pinholes, it will bubble and we'll know it, and obviously we would ship that unit. So may look like a simple test, but it's highly accurate, and it ensures that every single power meter we ever ship is watertight. So with all this said and done, we have power meters that have been through multiple steps of testing, both in accuracy, consistency, water, but we still want to go one step further. So we go through 25% of our power meters just as a double check to make sure and ensure that they're always plus or minus 2%.